Here again we have a type 2 projectile problem. A golf ball is struck and leaves the ground at 48 meters per second on an angle of 60 degrees. How far will it travel before the first bounce? And from our previous question we found the time to be 8.5 seconds. And so what's going to happen is our ball is going to take off or get hit and then take off at an angle of 60 degrees at 48 meters per second. And it's going to follow an arc, actually a smooth little arc through the air, and land somewhere over here on the far right. And so the question is what is this distance from the beginning right here to right here, this horizontal distance? So what we need to do is we need to find the horizontal velocity first. That's this velocity right here. We know the hypotenuse, we know the angle, we need to find the adjacent. So we're going to use cosine of the angle and adjacent over hypotenuse, but we need to isolate adjacent. So we're going to times both sides by hypotenuse over 1. And so on the right side, the hypotenuse cancel out, we got adjacent, and on the left side, we're going to have hypotenuse times the cosine of the angle. And then what we're going to do is substitute our numbers, and we're just going to flip it first and put the variable on the left. And for the hypotenuse, we got 48 meters per second. The angle is 60, so 60, and our answer is 24 meters per second. So you can see here our horizontal initial velocity is 24 meters per second. So what we're going to do now is use to find this distance. We know the velocity. We're going to use the third kinematic equation, which is d equals vt plus half at squared. Now, however, this ball that's going through the air has constant motion in the horizontal because there's no force acting on it in the horizontal direction. So there's no force making it go faster or slower. And thus the x component of the velocity is constant, and the acceleration in this x direction is going to be 0. So that's why we got a 0 there. And so we're going to substitute our numbers now. So we got 24 meters per second times our time from our previous question. Then we're going to put those numbers into our calculator, and we're going to get 203.6 meters. But we've got to look at the sig figs. We've got 2 sig figs here and 2 there, and that's our lowest number. So our final answer is going to be 2.4 times 10 to the 2 meters. Now we're just going to do a double check on our unit check. We got meters over seconds right here. We got seconds here, so s over 1. We're going to cross out these seconds and left with m over 1, which equals meters, is what we have right here. So our final answer, when the ball is hit at 48 meters per second at 60 degrees, it's going to go 240 meters.